and I want to pass this value to this accept method and perform some operation. Suppose in that I want to perform the operation like if value is equal to 0, I want to display system.out.println value is 0. Else system.out.println value is non-zero. Okay. Now here we need to save this into left side. We have not yet assigned. That's why it is giving the error. So here we need to use consumer reference. So I'm using C1 reference, and this consumer reference I want to be at the type. I want it should be integer. Okay, so the error is gone from here. Otherwise, you need to do the casting part. Okay, now after providing the implementation using the lambda expression, I'm calling this c1.accept method, passing some value, which is an integer value, and it according to this value given, it will check the condition and give the output. We'll execute this. So first, this is an example of consumer interface, which is taking the string argument. And the second one is value is non-zero, where we are using the lambda expression. Okay, so this is basically used for performing any operation which is required, and you can perform anything, whatever you want using this. You can call other methods also using this accept method. Okay, so this is the example of consumer interface. Now, next, the second type of interface is nothing but marker or tagged interfaces. Marker or tagged interfaces doesn't have any body. Okay, that means doesn't have any methods. It is or fields or anything, constants, nothing. It is an empty interface. It is an empty interface. Okay, in Java is known as marker or tagged interface. So it is primary function is to serve a means of making or tagging a class with particular characteristic or behavior. So making it special. So whichever class is going to implement that interface, which gives a runtime, at the runtime, it will give as it is a special class. Okay. So it will be considered as special class. So when a class implements a marker interface, it communicates to the compiler or the runtime environment that the class possesses the specified behavior associated with the marker interface. Okay, so examples of marker interfaces, built-in interfaces are there in Java are serializable, clonable, remote, and many others also. So serializable, we mostly use this serializable for serialization purpose. Then clonable is used for cloning, performing cloning operation. Okay, so if you want to use this, then you can use any of these interfaces. Just implement this interface so that it will be that class will be considered, it will be tagged, and it will be considered as a special class. So the example, serializable interface is like this. Public interface, it is an empty interface. Clonable interface is also an empty interface. Nothing is there in that interfaces. And we are implementing one class which implements the marker interface name. Whatever the marker interface you want to implement, you can implement it and give the class implementation. Okay. So here we'll create one class. I will show you the interface. The interface name is serializable. So this is an interface, serializable interface. It doesn't have any body, only it is an empty interface. Okay, it is known as marker interface. So when we implement this serializable, it is used for serializing purpose. It is used for writing our data, that means objects, into file, and deserialization, that means the data which is stored into the file or objects which are stored into the file, those gets deserialized and converted into objects again. Okay, so this is basically the classes that do not implement this interface will not have their state serialized or deserialized. So basically the serialization interface or serializable interface is used by the object output stream and object input stream classes for writing the objects into file and reading the objects from the file. Okay, so this is the serialization concept, and it is used for serializable. We basically use this serializable interface, implement this interface in that particular class, and perform these operations using object output stream and object input stream classes. Okay, so this is all about. We are not going to see because there is no implementation for the marker interfaces. So we are not going to see it. If you want to see, then you can so see this serializable interface. Then there is a clonable interface. So clonable interface. Clonable interface. This is also marker interface. It doesn't have any data into it. This is also empty interface. So clonable interface is used for object cloning. Okay, so object class has a clone method. So whenever you want to use, you can use, whenever you want to clone an object, you can use this clone method, and that time you can implement this clonable interface. Same like this, when you want to store the objects into the file or read the objects from the file using these two classes, object output stream and object input stream, that time you can implement the serializable interface by that class, and then you can use these two classes for performing read and write operations. Okay, so this is all about the interfaces. Here we have all completed with your interfaces concepts and the module 11. Now we are going to see the second, this module is collection framework, but that we will see later. Okay, because it has some concepts which you must know before learn those collection frameworks. Okay, so we are going to start with your module 13, that is exception handling, which is the most important concepts in your Java, because lot of the times we get some bugs, we get some exceptions, and how to handle those exceptions or errors, that you should know. That is, we are going to learn here into the exception handling concepts. So first, how to handle the exceptions, how to create the custom exceptions, that all things we are going to see in this exception handling. So first of all, what is exception? Exception is nothing but your program is working smoothly. Like here we have done one program. Okay, so suppose here we are going to create one program, exception handling. Okay. In this, I am including main method as well. So this is a program where I am creating a program for dividing value. Okay, so suppose I am defining a value A is 52 and B is 6. I am performing a program that is nothing but system.out.println dividing. Okay, dividing I am performing here. So suppose A divided by B is the program. Okay, this is a regular program. We are performing divide operation. So if I am executing this, we are getting the value, that is a quotient value. The division is 8. But suppose you are giving the divisor as a 0. You know that we cannot divide by 0. If you are dividing it by 0, then we will get the exception, that is arithmetic exception, right? So this is arithmetic exception, divide by 0. It is not possible. But at this time, if I am writing some program here at latter, that means I am writing some statements. end of example. If my program is correct and I'm executing this, all lines of code will get executed. That means with the end of example. Okay. But if any exception occurs, it stops abruptly in between. At which line? You can see here we are getting, this is an exception handling is the name of your class .java file, and after that colon line number 6 is there. So at line number 6 our program stopped working abruptly and it is completely stopped. It is not going to execute the next line of statement also. Okay, so this is what an exception is. It is nothing but a condition, or it is an unwanted, unexpected event which occurs during execution of program. A smooth programming execution is interrupted or disrupted the normal flow of the program's instructions at runtime. That is known as exception. Okay, and the error is basically it is a irrecoverable event, such as Java virtual machine JVM is running out of memory, some memory leaks, stack overflows. These are errors which are not created or not directly getting by developer. It is errors are usually beyond control of the developer or programmer, and we should not try to handle the errors. But exceptions we can handle because it is due to our program. It is execution is stopping in between. It is disrupting the normal flow of programming. So we can handle this using the exception handling mechanism. How to handle that we will see. So before going forward, there is an exception hierarchy. So you know that object is a base class for all the classes, right? So there is a throwable class. Throwable class is the parent for all exceptions. Throwable class is a parent, super parent for all the exceptions. Throwable has two child classes. First one is the exception and second one is the error. Okay, so all exceptions are enlisted, or all the exceptions are exception classes are under exception class. Okay, all different types of exceptions are there. Like here we have seen that arithmetic exception. Okay, this is arithmetic exception. So this is arithmetic exception is child of exception class. So runtime exceptions and all those. Then error is a class where we will get some different types of errors, which is irrecoverable conditions. We cannot handle the errors. Okay, and we should not try to do that also. So like virtual machine error, assertion error, etc. Memory leak, memory out of bound, etc. All those are errors. In exceptions, there are two different types of exceptions. First one is a checked exception. Second one is the unchecked exception. Checked exceptions are nothing but, which are also known as compile time exceptions, which we will get at the compilation time. For example, IO exceptions, that means input output exceptions. So when we try to read some files, that time we will get this IO exception, because file not found exception is that the compile time exception, which is if the file is not present, we will get it immediately at the compilation time itself. We don't have to wait till the runtime. Then second one is the unchecked exception, that is also known as the runtime exceptions. Or for example, the program which we have done here, that is arithmetic exception we are getting. This is a runtime exception. Why it is a runtime exception? Because our code is correct. We are not getting any error at the in the code, okay, or in the logic. Our logic is correct, but at some conditions it is failing to execute. Why? What is the condition? If we are trying to divide it by 0. So this will occur at the runtime itself. It will not occur at the compilation time. That's why all the unchecked exceptions are also known as runtime exceptions. For example, arithmetic exception, null pointer exceptions. Okay, so this is the exception hierarchy. Still, we will see the types of exceptions again. Here, there are two types of exceptions. We have already seen checked and unchecked exceptions. But there are two types of exceptions, that is built-in exception. These are all built-in exception. These have different classes already defined in the Java, in the java.lang package, all these exception classes are already defined with checked and unchecked exceptions. Second type is user-defined exception. User-defined exception is nothing but known as custom exception, which we will create according to our need. That means for our application, you can also use the exceptions part for exception handling. Or you can also show the proper message to the user using user-defined exception. Okay. So checked exceptions are class not found exception, interrupted exception, IO exception, instantiation exception, SQL exception, file not found exception. These are few enlisted. There are multiple. Okay. Now, few listed unchecked exceptions: arithmetic exception, class cast exception, null pointer exception, array index out of bound exception, array store exception, illegal thread state exception. Okay, so these are different unchecked exceptions which will occur at the runtime, and these are the checked exceptions which will occur at the compilation time. First, we have seen the types of exception, built-in exceptions. So we have already seen one example for the built-in exception, that is this arithmetic exception. If we try to use one more, if I am using string s is equals to null, then I'm trying to find out the length of this particular string. Length of string is equals to s dot length. So here this string object doesn't have any value. It is assigned a null value. So if we try to do this, it will throw an exception, that is null pointer exception. Two exceptions will not be thrown at the same time, because here we are not handling any exceptions. So these exceptions, if the first exception occurs at this line number 6, then your program will stop here itself. It will not go for the next line of code. But I have changed the code just to show this null pointer exception here. So you can see the null pointer exception is occurred at line number 10. Okay. So this is the exception in thread main. The type of exception is written here and where it is occurred. So module 13 exception handling is the package name. Main is the method. Okay. And module 13 is the package name. Exception handling is the name of our class. Main is the method. Then again, it was showing the name of your file, that is exception handling.java, then line number 10. Okay, so after colon, that is the line number 10. It is easier to see this trace. We can trace our exception occurred at which line of code, from where if we are calling the methods, then it is always used multiple calls, call stack also. I will show you that call stack so that you will go through that call stack and identify at which line of code you are getting an exception. So this is, we are not performing any handling mechanism here. So who is handling this particular, who is throwing this exception? Basically, the default handler is JVM. Okay, so default handler for the exception is JVM. JVM is handling this exception, throwing this exception basically. Second one is, all these are built-in exceptions. Now we are seeing the user-defined exception, which are known as custom exceptions also. So the built-in exceptions in Java are not able to describe a certain situation. For example, you're performing an application for age validation. You want to validate the age. So you can basically perform this. You can create the age validation exceptions and show the appropriate message to the user according to your custom exception. So here in such cases, user can also create exceptions, which are called user-defined exceptions or custom exceptions. The advantages of exception handling in Java is first, provision to complete program execution, easy identification of program code and error handling code, propagation of errors, meaningful error reporting, identifying error types. So the syntax for creating the custom exception is class, whatever the name you want to give to that exception, that should be the exception. Whenever you are creating the user-defined exception, that exception should extend the exception class or runtime exception class, because we are creating the runtime exception. Okay, so that is why you can directly create the child class of exception class or runtime exception class. This is, we will see the custom exception platform. So throwable class has some inbuilt methods. What are those inbuilt methods? First one is the get message. Get message method is used to retrieve the message from the whatever the exception is getting, that is get message. It will only give the message, detailed message. Then get cause. It will give throwable reference, the exception represented by the throwable object. Then the toString method is there. So toString method, you know that toString method is basically, it is a concatenated result of the get message. Then the void print stack trace. Stack trace, we as a developer, we mostly use the print stack trace method because we want to our stack trace to be printed and we can easily identify at which line of code our program is throwing an exception. So we mostly prefer print stack trace. It is basically a toString method along with the stack trace, that is system.error and error output stream. Okay, so what we are getting here as an output, this is the stack trace. Okay, so when we use this stack trace method, we will get the output like this itself. Then get stack trace, it is returning the stack trace element array, nothing but it only gives the arrays, array representation. Then last one is fill in stack trace. It is used to trace the throwable object. It fills the stack trace of this throwable object with the current stack trace, adding to any previous information in the stack trace. So these are throwable class methods which you can basically use for showing your exceptions. You can view your exception also on the console. Okay, so any of these method you can use for those purposes. So exception handling mechanism. As I said, by default, the default handler is exception handling the exceptions. That is, JVM is handling the exception. But as a programmer, we can handle the exceptions using few keywords. Those keywords, there are 5 keywords. First one is try, catch, finally, throw, and throws. These have different meaning and different purpose to use this. Mostly we use try block. It is a block. Okay. Try is a block. Whatever the code you want to monitor for any exception, that should be written inside this particular try block. Okay. So it will use to monitor the exceptions. Though it will occur or not, you need to use the try block. Whatever the code you want to monitor for the exceptions, you can write it inside the try block. So in this example, we will write this code divide statement in the try block. Okay, so simple use try as a keyword. Then the block of statement, you can write multiple lines of code into it also. Okay, so I am using for this null pointer exception also. I am using this. So this is a try block. Try is always used or followed by catch block or finally block. Okay, not always by catch block. You need to use try with finally or try with catch. Try alone will not work. So try block, we are writing the code inside the try block, which we want to monitor for the exceptions. Then the catch block. Second is catch block. Catch block is used for handling the exceptions. We can write multiple catch blocks also. 1, 2, 3 different types of catch blocks also. Only the thing here is important is the exceptions first, or the sequence of the exceptions should start from the child to parent. The parent should be at the end. It shouldn't be the first. Why? Because if we are using the first exception type itself as a parent one, then it will get catched here itself. Then there is no need of these, or it is dead code, you can say. Okay. So we will add here types of exceptions. Catch, multiple catch, we will add. Catch. After catch, you can write what type of exceptions we are getting here. First one is the arithmetic exception and second one is the null pointer exception. So we will try to handle both in a single catch. That means multiple catch. So first I will use arithmetic exception. You just need to create one object of it. This is a class arithmetic exception, okay, which is extending runtime exception. and this runtime exception is nothing but the child of exception class. So this arithmetic exception handles all the arithmetic related exceptions. Okay. So this arithmetic exception object we are creating here. So whenever the exception occurs, the default handler, that is JVM, creates the object of matching exception. If we have handled this by ourselves, that means we are writing the catch block for that particular exception. Then this catch block will catch that exception, handle that exception, and whatever you want to display, you can display it here by using the throwable classes method. So here I am going to show you the method get message. Okay. So using this object e dot get message, so it will only give you the message. We are handling the exception. That means our program is not stop at the line where the exception occur. It will execute complete code. Okay. It will not stop abruptly. It will not stop abruptly in between. It will execute complete code without any problem, but it will show you the exception if we have written the catch block. If okay, here you can use the get message method or print stack trace also. So print stack trace method I will show you in the next catch block. This catch block is going to handle this null pointer exception. Null pointer exception. Here I am creating another object of this, and we will simply use n dot print stack trace. Okay. All these are throwable class methods. So once I will execute this, your program will not stop execution. It will execute correctly. Okay. So first is dividation is done. Second, we got the null pointer exception at the line number 10, but our program is not stopped. It is terminated successfully with the end of statement. That means till last line of code, it will execute. It will not stop execution in between. Okay. So suppose you have the first exception occurred at the line number 7, that is divide by 0, then it will stop execution for the next try statements. Okay. And at which line of code it is executing the exception occur, it will immediately go to the catch blocks, checking for the appropriate catch block. If it is, we have written this arithmetic exception catch block, then it will get caught. If not, then it will be handled and execution will be stopped here abruptly in between by the default handler, that is JVM. I will execute this. You can see get message methods only give such type of statement, that is divide by 0 and the end of example. We are not getting the statements after the exception is occurred, that is line number 7. And we are not able to identify at which line we are getting this exception. That's why as a programmer, we mostly prefer stack trace method just to identify at which line of code is throwing an exception. Okay. So this is try and catch. So here I can add the catch parent exception, that is exception class reference also. And you can write print stack trace. That is also fine. If matching exception is not found here, it will go to the directly this exception hierarchy. That is it is a parent, right? So we can handle the parent, all types of exception using parent exception. So it will go to this catch block and it will execute the statements or handle the execution. So suppose, for example, we are not getting any exception here. Here also I am not getting any exception. And I am creating one array, integer array is equals to, okay, I will directly add the values. New int of 5. Okay, here I am giving the values. Sorry, brackets are wrong. So I am given the value as this arrays I am creating, okay? And I am trying to access the value at fifth index, which is not present, okay? So we are trying to access the value of the from the array at the fifth index, which is not present in our data, okay? Because we have already created the data into array. We have stored the data into array, and it is with the 4 indexes only. We don't have the fifth index. So if we try to access that fifth index value, it will throw you an exception, that is array index out of bound exception. So you can see array index out of bounds exception, index 5 out of bounds for the length 5. Okay. So where we are getting that at line number 13. So this is our program is not stopping at this statement, and we are handling it properly. We are getting the output exactly what we want till the end of program or last line of code. And this arithmetic exception is handled by this exception. Why? Because this, sorry, not arithmetic, array index out of bounds exception is handled by this exception catch block, because this is a parent and we are not mentioning anything here, array index out of bounds exception, right? So this is arithmetic, this is for arithmetic exception. This catch is only used for null pointer exceptions, and this exception catch block is used for all types of exceptions. Clear? Till here, anyone has any doubt? So you can write try and catch blocks, multiple catch blocks to one try. Yes. Till here, anyone has any doubt?
If we know what type of error it is coming, we can write it. Otherwise, it is better to write exception.
Yes.
Okay.
And the
so throw statement is going to throw only the user exceptions or any type of exceptions, right?
Throw we will see in the next part.
Okay. Okay.
This is just for try and catch blocks. How
Okay.
to handle the exception using try and catch blocks. This is what
Okay.
we have learned now.
Okay.
Okay. If we are writing the multiple catch blocks, the sequence matters, that I already explained. If you are trying to write this catch block at the first, then this 2 catch blocks will be the dead code, because all types of exception will be handled by this exception itself, because it is parent, right? So this will handle all the exceptions. Then there is no need of writing this. So it is a dead code. So we mostly use the sequence. The sequence of multiple catch blocks must be the exception hierarchy. Okay, that means the child class should be the first, then the parent one. Okay, so this is all about try and catch block. Alone try block will never work. It should always have a catch block or next block, that is a finally block. Okay, so third block is finally block. Finally block is, we can use it with the try block or try catch block, anyone. Okay, it always executes, though you have any exception occurred or no, not occurred, still this finally block gets executed successfully. So whatever the code you want to execute, compulsory, with the exception occurred or not, compulsory, that code you should write into the finally block. So finally, you can write here. So here, mostly we use this finally block for closing all the connections, closing all the streams, like in the file handling, if any exception occur, then we should close the files successfully. So though your exception occurred or not, the files should get closed. Same with the database connections. The database connections should not be opened if any exception is occurring. It should be closed. So the closing of all the resources, mostly we write into the finally block, but we can write anything which you need to execute compulsory. So here I am writing example of finally. So finally block gets executed your exception is occurring, still you are getting the finally block exam output. If we are changing it for, that means our program is not throwing any exception, still your finally block executed. Okay, so this is how the finally block works. You can write try with finally also. You can write try, catch, and finally also. Okay, you can write a single catch statement also, not compulsory you should write the multiple catch statements. And one more thing, catch statements you can combine using the this operator also. Okay, so suppose here I will combine null pointer exception and I will remove this. Okay, so this is also possible. We don't need this. So basically arithmetic exception or null pointer exception will be catched by the same block. So multiple catch blocks. In this way also you can write using the OR operator. Basically this is OR. We use this for OR conditions, right? So same this operator, dash operator, you can use for writing multiple exceptions in a single catch block also. This also should maintain the same hierarchy, that is the parent should be at the last, child class should be the first. This is the try, catch, and finally blocks, mostly used for handling the exceptions. Any doubt? Understood the try, catch, and finally blocks. What is the purpose of this try block? What is the purpose of catch block and finally block? And how to write it? You can write try with finally directly. You can write try, catch, and finally. Also, only catch and finally will not work. Only try will not work. Try, one try block will have multiple catch blocks. Finally block is always a single block. We never have the multiple blocks. Okay. One try will have one finally block. You can write multiple try blocks, nested try blocks also. That means inside the try, you can write another try also. And that try will have catch blocks, finally blocks, whatever you want. But try single-handedly never work. It should have either catch block or finally block to work. Okay. Whatever code you want to monitor for the exception, that you should write inside the try block. Catch is used for handling the exception, and finally is used to write execution should occur, or execution will be done though your exception occur or not. Okay. So why we use this, that I think everyone understood. Next, there are two more keywords, that is throw and throws. So throw is basically used for throw any exception. This is known as clause. Okay, throw clause and throws clause or statement. So exception, explicitly you want to throw any exception which is not handled by the that means you should have some condition and you want to throw yourself the execution or throw any exception. That time we use this throw keyword or throw clause. So mostly we use the throw clause for throwing custom exceptions, that is user defined exceptions, but you can throw the built-in exceptions also using throw clause. We will see one example with the custom exception itself directly using the throw statement in tomorrow's session. Next is throws keyword. Throws clause is used in the method declaration. The method declaration, which is using the throws clause and or throws statement, you can add any type of exceptions here, multiple exceptions also. So basically that method is going, maybe that method will throw any of these type of exception defined. Okay. This will also, we will see the tomorrow session. Okay. Understood the try, catch, and finally, anyone has any doubt in that? If we understand this concept, then throw and throws, you will understand it very easily. And this is most important part of your Java, because exception handling is important in your code. It should, your program should not, or your application should not throw any kind of exceptions while developing.
finally block will always execute whether the error is there or not.
Error. Exception is there or not.
Yes.
Error is different.
Okay, sorry. Exception is there or not, it will always execute.
Yes. Error is the irrecoverable conditions which we cannot handle. That means programmer never handle the errors. It is due to some hardware issue or
Syntactical error, semantic error, these are different type of errors, right? Total errors. Syntactic errors.
Syntactical errors, these are different.
Okay.
So what we
Hardware
are
error and the software errors, these are different. And again, related to code, these are different.
Yes, these are errors which nothing but the virtual machine error, then call stack error, stack memory is in, that means full, stack empty, etc. are the error type of error which is internally your you can say internally gets occurred due to some reason. That means if your JVM is not working properly, you will get the virtual machine error and you are not able to identify that. Okay, you will not be able to recover that. You need to uninstall and install the Java again so that your program will work. So these kind of errors, those are different. Syntactical error is different. That is not a part of your this hierarchy.
So for everything, there is a built-in class.
Yes, for all the exceptions which we have seen.
You have to just create the object and we will be able to handle it.
Yes, we just need to use it. If you want to create your own, then we will define our own exceptions using the exception child class creation.
Correct.
Okay, that we will see in the tomorrow session, how to create our own exceptions. That means custom exceptions.
Okay.
All these are built-in classes. These are already defined in the java.lang package. So according to your type of exception you will be getting, so you can use any of these. Okay, clear?
Yes, clear.
Okay. Thank you, everyone. Then we will end our session for today here. We will continue tomorrow with the next part.